So how could we find out the biomass of a tree? Well, if we know the dimensions of a tree, we can use another set of research, this time by Zianis and his colleagues, to compare the dimensions of the tree against charts which average out the biomass of trees of certain dimensions.
So Zianis' research has produced 3 charts, one for working out the biomass of the stem or the trunk, one for the canopy, and one for the root system. And what you can see here along the bottom is that we need to know the stem volume in order to work out the biomass. So once we know the volume of the stem, the trunk, we can work out, if we know what type of tree it is, so different colours of different trees, we can use that to work out on the chart what the biomass is.
Now this is going to get a bit mathsy, but the maths involved is stuff you would have covered at GCSE. I'm more of a visual person than a numbers person, so if that's you too, the diagrams in your worksheet should help you understand what we're finding out here. So a trunk of any tree is a sort of cylinder. Okay, so we've got a cylinder here. To find out the volume of a cylinder, you might remember from GCSE maths, is pi r squared h. Okay, so that's pi times the radius, so radius is part of the area across, and then we need to also know the height. Okay, so we need to know the radius and the height. So for its radius, we can't chop the tree in half and measure across the stump. But again, from GCSE maths, you might remember you can use the circumference and pi to work out the diameter, and then half of a diameter is the radius. So we're going to measure the circumference using a tape measure, and we'll do the maths later. So there's a standard height of where to measure this. So 140 centimetres from the ground is the sort of standard height to measure that. So I'm going to first of all measure up from the ground 140 centimetres. Okay, and once I know where 140 centimetres is, I'm then going to measure the circumference around the tree. And that is 139 centimetres, so let's write that down. Great, so what about the height? I can't safely or ethically chop the tree down, but again, I can use some GCSE maths to get its height. What we want to know is this measurement from the ground up to the top. And what we can do is take some measurements of distance and angle from the ground and use trigonometry. Again, there's a diagram of this to help you if you're getting a bit lost with all the visualisation. But basically, what I need to do is find a position where I can be level with the tree, so my feet are on a level with the tree, and if I look at the tree, I can see the top of it without massively moving my neck. Okay, so I can see the top of the tree. And what I mean by the top of the tree is where its branches start to split off. Okay, so that's the research Zianis did, looking at the trunk where the branches start to split off. So looking over in this direction, first of all, we've got the distance. So I've measured the distance. I've had someone holding my tape measure taut for accuracy, and I've got a distance of 6 metres 40 along the floor. The second thing I'm going to measure is the angle. So I'm going to use a clinometer. Can you help me measure the angle? You can also get an app which will help you to measure angle on your phone. And I need to point the angle to that point where the branches start to split off. So my angle is coming out as 50 degrees. So what we've just done is measured part of an imaginary triangle from me to the tree, up to the top of where the branches split off, and then back down to me. That's the triangle we are getting some measurements for. So we've got an angle over here, we've got a distance, and that's going to help us when we use trigonometry to calculate the height. Now what we haven't accounted for is the fact that I have measured the angle from my eye level. So as well as the height we're going to get from trigonometry, we need to add in the height from the ground to my eye level. So from the point where I measured the angle up to the branches, my eye level is 1 metre 65. So I'd write that down as well. Okay, so the fieldwork itself is pretty simple. We've measured the circumference of the trunk at 140 centimetres from the ground. We've found a position away from the tree, measured the distance to it, and measured an angle plus my eye level. So just 4 measurements. Okay, so that was quite a lot of maths to visualise, but it's quite good to know where the numbers come from before we start doing the maths. One habit that's really good to get into is to estimate the result we're expecting. So I might look at that tree and say, up to that place where the branches split off, that's about 8 metres. I'm probably not going to be bang on, but I know that if I get a result of 2 metres or a result of 68 metres, that there's definitely something gone wrong. So that'll help me with making sure my data is correct.
Okay, so we've got our numbers recorded on our sheet, and we're now going to do the calculations to work out how much carbon there is in that one tree. So you'll need your booklets in front of you and a calculator as well. So the first bit we want to work out is the volume of the trunk, which we said is basically a cylinder. So a cylinder is pi r squared h, pi times the radius squared times height. So the first number we're going to go back to work out the radius is the circumference. We want to get a radius. To work that out, we first of all need to work out a diameter. So diameter is circumference divided by pi, which is 0.44. Half of that gives us the radius. So diameter divided by 2, 0.22, and we can put that into our volume equation. The next bit is to work out the height. So we worked out that we could calculate this using trigonometry. So the calculations are based on the numbers we have already measured. So we measured the adjacent, the distance between my feet and the tree. We measured the angle to the top of the trunk, which was 50 degrees. We measured the height from the floor to my eye level, which was 1.65. So to put all of those together, you might need to do them separately on your calculator in little sections. So we're going to do 6.4 times by tan of the angle of 50. And then we're going to add to that 1.65. So that gives us a height of 9.28, which is not too far off my estimate of 8 metres. It was in the right ballpark. So again, I can slot that back into my volume calculation. So the final bit is to put all those numbers together. So pi times the radius squared, so pi times 0.22 squared times by 9.28. So the volume of that trunk is 1.41 metres cubed. So the next stage is to go back to the charts provided by Giannis and work out what that means for biomass and therefore what that means for carbon. So the volume of the tree was 1.41 metres cubed. The diameter, we've already worked that out, it was 0.44, and that's the same calculation that we need for the roots and for the crown. So here is our chart for the stem volumes, the first bit, the trunk. So we know that our volume was 1.41 metres cubed, so we find that on the chart. And then we go up until we get to the type of tree we had. So in our tree's case, it was a beech, which is the dark blue line on this graph. And then we can work across to work out the biomass. So that's 0.65 tonnes reading off that scale there. To work that out into carbon, we divide that by 2. The next stage is to go back to our diameter for the roots. We've got a different graph here, different chart. And exactly the same again, so I'm going to find 0.44 on my x-axis, and I'm going to follow that up to the dark blue line for beech, and then across to work out the biomass, which in this case is 0.25. Again, divide that by 2 to get the carbon. And then finally the crown. Again, we need the diameter. Similar process, find my diameter measurement, work out my tree type, beech, go to the dark blue line, and then work my way across. And I've got my biomass of 0.23 tonnes, giving me a carbon content of 0.115 tonnes. So to work out the total carbon for that tree, all I need to do is add those together. And that gives me a carbon content of 0.565 tonnes for that one tree.
Great, so we've worked out the amount of carbon in one tree, but what does that mean? Is that a lot of carbon or not?
A quick internet search will give you lots of results for how much carbon is within different activities, but most of these are measured in CO2 or CO2 equivalent. So to know how much carbon within that, we need to look at the atomic weights. So carbon has an atomic weight of 12, oxygen 16. So 1 carbon and 2 oxygen is 44. Hopefully this is ringing some bells with GCSE science. So to look at carbon within carbon dioxide, we need to do 44 over 12. So we're going to use the number 3.67. If we have a measurement of carbon dioxide and we want to know how much carbon is within that measurement, we would divide by 3.67. If we have a measurement of carbon, we want to know how much carbon dioxide would hold that much carbon, then we need 2 times by 3.67. So for our tree, which had 0.565 tonnes of carbon in it, if we times that by 3.7, we get to 2.07 tonnes of CO2. Now if we have a look at this graphic, which comes from the BBC, that is roughly equivalent to living car free. So for 1 year, not having a car or not using a car is the equivalent carbon saving that is contained within that one tree.